Let's look at expressing the confidence in finding using statistics. The purpose of testing a sample mean is generally to test out whether it equates the population mean. But the testing or sample mean has two purposes. One is to estimate the population mean with a confidence interval. The confidence interval is generally 95%, within which we expect the population mean to lie, estimated from the sample. The second purpose is to test a hypothesis. In that, we expect the sample mean to be equal to the population mean. If that is confirmed, if the sample mean does not equate to population mean, we reject the null hypothesis and accept the alternative hypothesis. Let's look at the first purpose. Purpose of testing sample mean is to equate the population mean, but our first purpose is to estimate the population mean with a confidence interval. The confidence interval is generally 95%. We can estimate for 90% and 99%, but the norm is 95% in business research. So we conduct 4 steps. First, we compute the mean of the sample. So we sum all the observation values and divide by the sample size to obtain the mean of the sample. Second, we compute the standard deviation of the mean of the sample. We take the distance of each observation from the mean we have computed and square it, and then divide by sample size minus 1, which we call the degree of freedom. Now that square difference, which we squared to get around the plus and minus and to add all the differences, we square rooted that computation to come up with the standard deviation or the mean of the sample. Third, we compute the standard error of the sample mean. That is the amount of the error of the mean. We compute that by taking the standard deviation of the mean of the sample and divide that by the square root of the sample size to standardize per observation, and that becomes the standard error of the sample mean. To estimate the population mean from the sample mean that we have computed and the standard error of the mean expressed at 95% confidence interval, we take the mean value. If you don't know the population standard deviation, we look up the t-value tables, and for that, when the sample size is greater than 100, the 95% confidence interval is 1.96, and in this instance we are assuming the sample size is greater than 1.96. The sample size is greater than 100. Therefore, the t-value is 1.96 for 95% confidence interval with two-tail testing. And we multiply that by the standard error of the sample mean. But when we express the confidence interval, we express as a range from the mean it could be above or below the mean, that range. So mean plus 1.96 into standard error of the mean, and mean minus 1.96 into standard error of the sample mean. So that's how we express and estimate the population mean from the sample mean. Let us now look at, once we have estimated the population mean from the sample mean, and we compare that with the hypothesized mean to see whether the hypothesized mean equals the estimated population mean. We have three samples: large, medium, and small. If the hypothesized mean of the large sample is 1.9, medium sample 10, small sample 58, and the sample mean is 0 in all three instances, we estimate the confidence interval assuming that we don't know the population standard deviation, and the standard error of the mean is given to us for large sample as 1, medium sample is 10, small sample 31.65. We compute the confidence interval using the t-value, that is the degree of freedom. Sample size minus 1 is degree of freedom. Confidence interval equals sample mean plus or minus t-value into standard error of the mean. And for large sample, it lies between minus 1.96 and plus 1.96. When we compare 1.9, it is within that range. It is within the range of the population mean that we estimate from the sample mean. So therefore, we accept the null hypothesis. For this medium sample, we estimate the confidence interval is between minus 19.8 and plus 19.8. The hypothesized mean is 10. It is within that range. Therefore, we accept the null hypothesis. For the small sample, we estimate the confidence interval is between minus 71.4 and plus 71.4. Our hypothesized mean is 58. It is within that range of the population mean estimated from sample. We accept the null hypothesis. Let's take another scenario. If the hypothesized mean is 0.9 and we compare with the confidence interval of the large sample minus 1.96 and plus 1.96, it is within that range. We accept the null hypothesis. For the medium sample, hypothesized mean is 12. The confidence interval is between minus 19.8 and plus 19.8, within which the population mean lies. And the hypothesized mean is within that range of the population mean. We accept the null hypothesis. For the small sample, hypothesized mean is 80. Confidence interval of the population mean to lie is between minus 71.4 and plus 71.4. It is outside that range. Therefore, we reject the null hypothesis. What we mean there is that the sample from which we have obtained the hypothesized mean does not belong to this population. It lies outside this population. We reject the null hypothesis. And for the large sample, t-value is 1.96, and the range within which the population mean will lie is minus 1.96 and plus 1.96. When we test hypothesis, null hypothesis we express as estimated sample mean equals the population mean. And often that has a value. Sometimes the sample mean estimated and the population mean, they are equal, but they are equal to 0. So that's the null hypothesis situation. The alternative is that they are not equal. Sample mean and the population mean is not equal. We can test the hypothesis in two directions. At 95% confidence interval, if we test it at two directions, that means that 5% significance outside the confidence interval level lies in both sides as 2.5% and 2.5%. We can test in one direction as a positive expression. That means that 5% significance level lies on the right side. We can also test the hypothesis as a negative direction, where we express the 5% significance level outside the confidence interval lies on the left side. And examples of those are when sample mean equals population mean. Two-tailed testing is mean class mark is 50 out of 100. But if we want to test as a positive, we say mean class mark is more than 50 out of 100. If you want to test it as negative, we say mean class is less than 50 out of 100. In the second scenario, we express or we assume that the sample mean equals population mean, but it equals 0. In the null hypothesis situation, we say, for example, mean firm size has no effect on corporate philanthropy, 0. If it has a positive effect, then we are testing the alternative hypothesis. If it is negative, we are testing the alternative hypothesis because there is an effect in both instances. We say mean firm size has a positive effect on corporate philanthropy. If you want to test it negatively, then we say mean firm size has a negative effect on corporate philanthropy.